Hi everyone, welcome back to Newegg TV. My name is Paul, and we also have JJ, special guest from ASUS.
Thank you.
Thanks for coming by, JJ. Today we're going to be doing some overclocking demonstrations with these new AM3 Plus motherboards, specifically the Crosshair V Formula. JJ brought by, and he wanted to show us some of the overclocking options, as well as a demonstration of the Uefi BIOS situation that is set up with the new AM3 Plus motherboards that ASUS has spent a lot of time developing. So we're going to do a little bit of that. We're also going to jump into the operating system and show you guys some operating system-based overclocking techniques. And just generally speaking, giving a little bit more information on what it's like to use these boards. And if you guys are wondering, the CPU that we're going to be running today is an AMD Phenom II X6 1100T. Mm-hmm. So JJ, let's start off here and maybe just take a look at the Uefi.
Yeah, definitely. You know, first and foremost, thank you for having me out here, and we're definitely going to hopefully give you guys some information regarding AM3 Plus overclocking on as it relates to the 900 series motherboards. Before we jump into the Uefi and some of the options that we're going to have available here for users on overclocking, I just want to kind of go over some of the kind of tenets on what users might need to know when they're going to be considering overclocking on an AMD platform. So first and foremost, of course, is that there's no guarantees with overclocking, as we know, right? So you're going to always have some variance within the potential of what the CPU has. Some of them might be able to be 3.9 gigahertz, some might be 4 gigahertz, or, you know, hopefully what we'll be showing you here is 4.2 gigahertz on this 6-core based CPU. But there is always going to be that variance. Now, as a user, though, you definitely always want to keep in mind that different parts on a system are going to help to contribute to higher potential, right? So part of that, yes, comes from the work that we're doing on a board level in terms of maybe our VRM and the high quality DigiPlus that we have and that we're offering to give you power delivery for the CPU and overclocking. Part of that might be coming from the tuning that we're giving within the Uefi, but then other parts of it as well are going to be definitely things like, you know, this H60 water cooler, right, that we're utilizing in terms of making sure that we have solid temperatures under load, you know, good quality power supply, and of course, good RAM. So all those things need to come together when we're talking about overclocking. Now, some things that sometimes users don't necessarily always realize when they're taking a look at how to overclock a system is what options might work right for them. So we're going to initially be going over the easy mode first in terms of some of the options that provides you. Then there's kind of that next step up for kind of more advanced users that they might want to dive into the advanced section of the Uefi and have all those complex voltages and multiplier ranges available to them and how they might tweak and tune that. And then we're going to maybe be showing something new, which is doing it on the fly within the operating system, but still having access to a lot of those low-level controls. So a lot of things to take in consideration. But one of the other parameters, too, is when we get into the Uefi, if we go ahead and we jump here into advanced, and then we go over to our memory frequency, is that there's different DRAM specifications that are supported for the AM3 and AM3 Plus platform. For the upcoming AM3 Plus, it is officially supporting up to 1866 in terms of the memory. For current AM3, officially, it only goes up to 1600. Anything over that is technically 100% of an overclock. So take, for example, here you see we have some different DIMMs, right? Now, most users might think that there's probably no difference between maybe 2 DIMMs or 4 DIMMs or anything along those lines. But there actually is quite a bit of a difference. Right now, we're actually running 4 DIMMs, and they're each 2 gigabyte DIMMs on the system. Now, this is going to be quite different than if I was to decide to run maybe like this Corsair Vengeance here, and these are 4 gigabyte DIMMs that are 1600. When I go ahead and overclock memory and at higher densities, it puts a lot of stress on the CPU and what's called the IMC. So the more memory, the higher the frequency, the more stress I place onto the IMC, the integrated memory controller. And that also corresponds to potentially how high a frequency for the CPU that I can go ahead and achieve. So let's say 4 gigahertz with 1600. Maybe I can only hit 2 DIMMs, 1600 at 4 gigahertz, not necessarily 4 gigabyte DIMMs at 1600 and 4 gigahertz.
So greater density of the DIMM that you have installed, as well as having multiple DIMMs, say 4 instead of 2, you're going to maybe run into a few more problems if you're trying to overclock.
Yeah, definitely. So you kind of want to go in baby steps, you know, and keep that in mind as a user. You know, if you're more interested in going for a high amount of density as far as memory for your system, you know, maybe you're going to be looking for a little bit more professional workload environments, like you're doing a lot of Photoshop work, video editing, where you need 16 gigabytes. Realize that you still will be able to probably overclock the platform, but maybe not to the same degree if I was to go with 2 high speed, maybe just 2 gigabyte DIMMs. So just something to kind of keep in mind. Okay, so we'll go ahead and jump back out here quickly to the easy mode interface. And the easy mode interface is actually part of what's called our Uefi, our graphical user interface. Not only does this give us the ability to go ahead and run larger than 2.2 terabyte hard drives, but it also gives us a lot of flexibility in terms of information and overclocking and adjustment to boot drives. So we can see here, we actually have a couple of different presets, and these presets execute different functions. This one will go ahead and do a quick undervolt of the CPU, but still keep us at stock frequency. This one goes ahead and keeps us at stock frequency operation with stock voltage. And this one's going to go ahead and be actually a quick overclock. So for users that really have no experience at overclocking their system, they could go ahead and just click this button, just like they could maybe access this OC button and get, you know, between 3.6 to as much as 3.8 gigahertz just from the click of the button. So that's very easy. But seeing as we're Newegg here, we're a little bit more of enthusiasts, we were going to dive into the UEFI in the advanced mode and kind of show users what they can do when they go into the manual aspect of it.
Sounds good.
So we're going to go ahead and jump in here to Extreme Tweaker. Once we get to Extreme Tweaker, we can see that we've got a couple of really nice options that are laid out. I'll go ahead and use my mouse since that's available to me. And we can see that our target CPU speed is currently 3.3 gigahertz, which is the peak of our 1100T processor. We want to go ahead and try to shoot for 4.2 gigahertz. So that's going to give us almost a 1 gigahertz overclock across 6 cores. So that's pretty nice. So all the user at this point would have to do is go ahead and go to the CPU ratio and go ahead and define the value that they're interested in hitting. So we're going to go ahead and apply a 20 multiplier, and that multiplier is going to go ahead and work against the CPU North Bridge frequency, and that value is going to go ahead and define our target speed. In addition to that, we're going to go ahead and disable the AMD Turbo Core technology because we don't want the frequency to potentially overshoot what we've already defined. Some users, when overclocking, they might leave turbo enabled but forget to compensate for more voltage to be required once turbo kicks in on top of the frequency that you're already trying to overclock to. So we want to work with fixed values to make things a little bit more stable in terms of knowing what we're shooting for. Next setup is we're going to go ahead and define a memory speed. And as you can see here, officially, we only go up to 1600, correct? So we can go ahead and select that value. Now for some users that are maybe interested in only overclocking their memory, we do give you a lot of options though. So users could actually go here to the DOCP option, which is ASUS's internally developed memory algorithms. And we can go ahead and actually select quite a bit more values than 1600. Our OG development team has set world records in terms of memory performance. So we have a lot of customization ability so that if you buy kits that are rated for greater than 1600 speed, they can go ahead in here and easily select, you know, 1866, 2000, 2133, even greater than that. But once again, it's very important to remember that those numbers are going to be not sometimes always achievable depending on the CPU and the memory that you pick. It's also important that you guys take a look at the memory. Some memory might be only rated for an Intel specification, not necessarily an AMD specification. Take, for instance, these Corsair kits. Corsair has done a great job, and they validated for both the AMD platform and for the Intel platform. So we know these specifications work fine for both, but not all memory kits are going to be the same.
Now, if I'm attempting the overclocks here and I say bump it up to a higher frequency, what's worst case scenario as far as what will happen if it actually can't boot at that frequency? Worst
case scenario, the system is going to probably lock and it won't necessarily post. In most situations, our board pretty has a strong auto recovery, so it should bounce back and let you know overclocking failed. But in worst case scenario, the user could go ahead either click the clear CMOS button, which is back here on the motherboard. If they have ROG Connect connected to like a notebook, they could also clear the CMOS that way, or they could also hit this Memo K button and reset it that way. The nice advantage of the Memo K is that if you have other values defined in the UEFI, like maybe like boot priority, fan speeds, things that don't relate to the overclock, that's only going to reset just the frequency information, and all your other settings get to be applied, where if you do clear CMOS, it wipes everything. So you get some flexibility there. The only other item that I want to touch on here in the DRAM OC is that this one's pretty cool. Now, a lot of people know about XMP, which means that I can buy a kit, and that kit has a predefined kind of a written information table that if I put that in and select XMP, it will go ahead and assign all that information. That's not available on Intel. Excuse me, that's not available on AMD. It's only available on Intel platforms. So what we have available here is we can actually read that information from the XMP table, and we can still apply it to the AMD system. So we give you a lot of flexibility in that regard.
Very nice feature.
Yeah. So we're going to go ahead and keep it though just a manual, and we're going to go ahead and go to 1600. Okay. From there, we're just going to go ahead and make some quick adjustments because we're going to leave the board set to pretty much auto. We spend a lot of time to actually make sure that the auto rules are quite robust. So that means that the user doesn't really have to go in here and go through every single item and make all these adjustments. So we're just going to go ahead and quickly define our key voltage. So we're going to go ahead and do 1.5 volts. We're going to raise our CPU north bridge a little bit more. The main reason why is the north bridge is important in terms of helping to handle information from our CPU as well as our memory. So we're just giving it a little bit more voltage to maintain stability. And we're going to go ahead and set our DRAM voltage as well. So we're going to go ahead and set that to 1.5. And we can know what our actual DRAM voltage is by also just moving over to our tool option and going to SPD information. Here we have a special tool that we can see the memory that we're using is rated for 2133, so here, and 1.5 volts. So I can go ahead and back out to that and know that I've essentially set all my corresponding values. So I'm okay there. And from there, the Digi Plus VRM options allow me to make some other configurations. But for these guys, we're going to essentially leave these to auto. So from here, we're going to go ahead and save and reboot. Okay, so we've gone ahead and dialed in all our settings now. So we're at 4.2 gigahertz. We set the HT bus at 210, the corresponding multiplier to 21. We defined all our core voltages and everything else. We've gone ahead and set our load line calibration to extreme. And so now we're going to go ahead and quickly boot into the OS, verify that our overclock is maintained, and we're going to be good to go. So this gives you a little bit kind of a base idea on some of the options you have available within the Uefi and how to overclock the system. One important word that I do want to go ahead and note is that stress testing is always an important part of the overclocking process. And it's one thing you don't definitely want to overlook, is that even though now we've successfully gone ahead and booted into the OS, there are a couple of things you can do to go ahead and take upon checking your actual overclock. Now, some users will go ahead and utilize applications like Prime 95 or Lynx, and this isn't necessarily a negative aspect, but they generally will only stress test the CPU and to some degree the memory depending on how you define those programs. The disadvantage of that, though, is that an overclock system will affect all parts of the computer. That includes my graphics card, that includes my storage array, my USB 3, all kinds of other devices. So generally what my recommendation is feel free to go ahead and use something like Lynx or Prime 95. But you might also want to use something like PC Mark 7, 3D Mark 11, real-world games, web browsing, video decoding, Blu-ray playback, whatever it might be that mirrors your normal work usage, because those things are going to go ahead and stress other parts of the system that you might not realize that your overclock has affected. And that's very important in terms of helping to ensure the long-term stability of your overclock. So we're going to go ahead and now open up our ROG CPU-Z edition, and this is going to go ahead and allow us to confirm our overclock setting. So we can see here we've got 4.214 megahertz, and it is corresponding correctly to also our bus speed and our multiplier that we went ahead and defined. And we'll also go ahead and confirm on the memory as well. And there we can see we've also overclocked our memory. It's a little bit over 1600 because we also made an adjustment to the actual, to the HT bus speed, which has gone ahead and pumped up our memory value. So we'll go ahead and corroborate that here in Ada as well. So there we can see we've got 4.2, and we have our memory here at 1686. So overall, a very solid overclock that would give you a significant increase in performance, especially when running multi-GPU. That's always a key time that you want to maybe start considering an overclock, is if you're running two-way or three-way enabled systems. You've got a lot of GPU bandwidth. You want to have a fast enough CPU to be able to take that data and be able to crunch it down.
So now that we've gone ahead and verified that the overclock is working, that we've booted up within that, are we going to run a little maybe stress test to make sure that it will verify under load? Yeah,
we're going to go ahead and do that actually when we go into the next part, which is going to be software-based overclocking.
Alrighty. Alright guys, so next up, JJ is going to show us how to overclock from within the operating system using the ASUS AI Suite 2 overclocking software. But first, some quick notes about if you want to do some pre-overclocking of the memory from within the Uefi.
Yeah, that's correct, exactly. The main thing is that we have a lot of functionalities available within AI Suite 2 within the operating system. You can do pretty much everything you want from a voltage and multiplier table, but if you do buy overclocked memory like 1600 and you want to go ahead and define that first, you're going to want to go ahead and jump into the Uefi and either go ahead and select the memory frequency from just the normal memory divider, or if it happens to be in excess of 1600, you can go ahead and go to the DOCP value as we discussed before, and we could go ahead and select like 1866 or 2133, whatever the value might be. But keep in mind the previous warnings that we described about DIMMs, density, and that corresponding kind of overclock and how that can affect all that. But for right now, we're going to go ahead and just start off 100% stock so that we can see the flexibility that's brought about by doing things within the operating system environment. So we're going to go ahead and just default everything and save, and we'll go out of there.
We'll just give a few seconds to boot into Windows.
Yeah, it should be pretty quick. We're using a nice SSD, so the boot process is going to be pretty fly. One nice thing, too, to also keep in mind is that for people that are utilizing the ROG board, they could also keep the ROG Connect externally connected and allow them to have a lot of that information in terms of temperatures and things like that, so that if they want to keep their screen with their stress test application and the ISV2 application, they can keep all their monitoring externally and have all that information available to them there. Now, as far as the ASV2 overclocking, that is going to be available on all the AMD boards that we've already previewed here in our other videos. So all the functionality that we're showing you here is available on all the boards. The only difference you'll see is that in the ROG version, which we haven't updated to specifically in this installation, it's going to be a red-themed ASV2, but otherwise it'll pretty much give you the same level of functionality.
But nice to have the same color scheme.
Yeah, yeah. So we've gone ahead and booted into the OS here, and we're going to go ahead and now open up CPU-Z again. And so this is going to go ahead and allow us to check on the actual CPU frequency as we're adjusting it real time. We could also go ahead and open up Ada, which I personally recommend in terms of a monitoring application and stress test application. They do a lot of work to actually develop their programs hand in hand and lock in step as new chipsets and new CPUs come out. So we'll just go ahead and have these both available for reference here. And next we're going to go ahead and open up the ASV2 from the system tray. Okay, so we're going to see a couple of different options. One of them is going to be tool. We're just going to go ahead and click on first Digi Plus VRM. Now we've discussed Digi Plus VRM and a lot of the benefits it has, and essentially what we can do here is we have the full Uefi hardware level controls available to us in the OS. And what that means is like things like load line calibration, North Bridge load line calibration, OCP, which is current, in terms of being able to increase the amount of current that we're going to be supplying, which at higher level overclocks we need to go ahead and bump up. These are all adjustable real time in the OS. So as a user, if I want, I can go ahead and just click on this, and this will go ahead and compensate for any droop that I might get to my core voltage. And I don't even have to make any reboots. Right now, we're just going to go ahead and leave these values to essentially all their default presets. And we're just going to go ahead and first jump into Turbo V Evo and show you some of the adjustments you're going to see. So we've gone ahead and now gone into Turbo V Evo. We can see here that we have our core voltages, our bus speeds, our advanced voltages all available to us real time, right? And here's our multipliers. Now, one cool thing about AMD that you also want to keep in mind is that we have the ability to independently adjust the multiplier per core. Now, the reason why that's important is because you might be able to achieve maybe greater than 4.2 gigahertz, but maybe on less cores. And that's important because maybe if you're a user that's utilizing a less multi-threaded application, maybe you want to go ahead and only overclock 2 or maybe 3 cores or 4 cores and get higher frequency than you would if you were trying to actually overclock all 6 cores.
So it's a bit more difficult to obtain a stable overclock with all 6 versus maybe just bumping up a couple?
That's correct, most definitively. Anytime that you try to overclock across all the cores, as well as overclock with fully populated DIMMs and DIMMs of larger density, you keep increasing the complexity level and the difficulty of being able to maintain stability. So all things to keep in mind. Now we're going to go ahead and make things even more difficult. Normally a user would go ahead, go into the Uefi, define all their options, define their voltages, reboot, open up everything, stress test, then walk away, come back and kind of keep going through this recycle process, right? Well, by doing everything actually real time within the operating system, I can go ahead and open up Prime 95. I'm going to run this full real time as it is right now. You can see here in our task manager, it's actually running full. The nice thing about ASV2 is we don't actually need to open all these other extra programs because here, if I were to click away out of CPU-Z, it's already showing me the CPU frequency. Here it's showing me the actual CPU utilization, and I can even switch over here to the monitor tab, and I can go to sensors, and I can see my CPU temperature. So pretty much everything that I need is all available to me in a single application. So that's already convenient in itself, right? So next step would be, let's go ahead and now raise the actual frequency. So as we can see right now, we're at 3.3 gigahertz. So let's go ahead and go a little bit more. We can go maybe 3.5. And we'll go ahead and make that adjustment to all the cores. And we'll go ahead and apply that. And this is going to work through our Digi Plus VRM, our TPU, and our iRAW controller all on the motherboard. And that's made those adjustments all real time, even with Prime 95 working simultaneously. So we can see here now that we're 3.5 gigahertz, and we've made that change live in the OS while it's running the stress test. That's pretty cool.
Did you guys catch that? He's overclocking while Prime 95 is running.
Yeah. That's not something you would be able to do when you're running in the Uefi or running in the BIOS. So there are a whole bunch of diehards that say Uefi is the only way, but there's a lot of perks that you have here because now I'm doing the stress test as I'm doing the overclock. And the reality is that in most situations, stability, if it's going to fail, it's usually going to fail within about the first 10 seconds to maybe at max about the first minute. And sometimes very long extensive testing, it might fail maybe after about 3 hours or 4 hours. But in most situations, failure is going to occur pretty immediate. So at this point, I could wait maybe, you know, a couple minutes, 5 minutes, 10 minutes. You be the judge in terms of what you feel comfortable with. But for this case of this video, we're going to go ahead and just keep moving along because we can see, okay, everything's gone ahead and maintained stability. I still don't see any problems. My CPU utilization is all still fine. I'm good. Let me go ahead and go more. But now before I jump any more, maybe I want to go ahead and give me a little bit more voltage. So I can go ahead and bump the voltage. Now, some users are going to want to go ahead and go in finer increments and adjust the multi, go in finer increments. What I'm going to go ahead and do is maybe go to a bit higher voltage. So I'll go to something like maybe 1.45. Now, this is going to go ahead and give me a much higher value, but what will allow me to go ahead and do also is I could just keep scaling up the CPU frequency until I essentially hit a wall. Once I hit that wall, I kind of know maybe I'm going to need more voltage or maybe I don't feel comfortable exceeding that. So you could kind of pick your mark in terms of what's your max comfort voltage and then just keep raising up until essentially you don't have any more stability and it fails the test. So a lot of flexibility you have there. Now, I'm going to go back to the GG plus VRM, and because we're starting to get to some higher CPU frequencies, I also want to go ahead and enable the load line calibration. So I'll go ahead and just set these to extreme, apply that, and that'll go ahead and execute now my load line calibration. So I'm going to go now back to the Turbo V, and we're going to go a little bit more. So we'll go to 3.7. And we'll go ahead and apply once again. So we can see here, now it's once again also made the adjustment here to 3.7, 3.7, and 3.7. So we keep scaling up. It's pretty easy. And the board is also doing a whole bunch of auto adjustments on a low level to correspond to the adjustments that we're making within the OS. So our board is also making these kind of like little micro adjustments in terms of other more complex advanced low-level rules that are helping us to scale this overclocking process.
So you can really do a lot more tweaking, a lot more fine-tuning at this level, and not have to worry about a reboot every time, getting back into the operating system, starting up a load test. You got the load test running.
Correct.
You
can just keep essentially scaling. And one other nice benefit is that in some situations when Prime 95 fails, what you might get is you might just get one worker to fail. And the OS will still be 100% running. And the cool thing about being on the OS is that what you can go ahead and do is, let's say maybe you went up to like 3.9 and one worker failed. Well, guess what? I can maybe drop back down to 3.8, readjust my voltage, and then reapply, and then relaunch Prime 95 and have it re-execute against all 6 cores. So I even save another reboot that's not needed. So it's pretty easy, you know, and you can essentially just keep scaling up. You know, we've got a pretty solid cooler here in terms of this H60, so we've got a lot of flexibility. So let's go ahead and just go maybe a little bit more. We can go see if we can do 4 even. So we'll go ahead and jump all the way up to 4.
Now for our users at home who are running these overclocking testing, maybe doing the same methods that you're using here, would you recommend once you've settled in on the overclocks and the settings that you want, running an overnight test just to make sure that you're stable across the board?
You could definitely go that route. Now, as you see right there, we ran a little bit too high, and maybe I needed a little bit more voltage, and the board shut down. So there's other options that we have available to us, but the thing that we saw is, of course, that everything was scaling normally, and it was still executing correctly. So at that point, now I can go ahead and restart the system, and I can reboot back into either the Uefi and use those defined values that I had available to me, or I can go back into AI Suite 2, and I can actually save a profile within AI Suite 2 for that overclocked value. But either which way, you can see you get a lot of flexibility available to you in going in within AI Suite 2 and defining those values. But you're definitely 100% right in terms that if you're looking for more stability, you can go ahead and run more extensive testing if you'd like. It really just depends on the user.
It definitely saves a lot of time being able to do those tweaks and not have to keep constantly rebooting every single time, going back into the EFI or the BIOS if you have an older system, and you know, all the time-consuming stuff that is involved with overclocking and testing and verifying to make sure you're stable.
Yes.
So the shutdown that you guys saw a couple seconds ago was caused by the overcurrent protection, which was set to the default value. But since this is an enthusiast board, we do have the ability to increase that value. So JJ is just bumping that up as well as a few other settings, because we really wanted to hit that 4.2 gigahertz overclock. So what have you done for the some final settings that we have here, JJ?
So I've gone ahead and actually enabled quite a number of other options here. So my core voltage is actually the same at what I had defined before, which was 1.5 volts. I've gone ahead and upped my actually CPU north bridge voltage to correspond to the fact that I'm running 4 DIMMs at actually an overclocked frequency as well. I went ahead and maintained my multiplier at a 20 value, but adjusted the CPU bus, HT bus, to 210, which is going to overclock my memory and my CPU as well. Now, in relation to what you just discussed, which was the OCP, I went into my Digi Plus VRM, and this is the benefit of us having that digital VRM design with our ASUS 2 package, is that we can make all these adjustments real time in the OS, not just on ROG, but the other boards as well. But here you can see that I went ahead and adjusted the CPU overcurrent protection, as well as the CPU north bridge overcurrent protection, because that helps me to increase memory overclocking performance. I went ahead and bumped those up. And now from here, I'm going to go ahead and you can see we're essentially almost at 4 gigahertz right now with the 3.99 and that slight bump up to the HT value. And now all I'm going to do here is go ahead into 20 and solidify this for that 4.2. And from here, of course, as we previously discussed, should the user want to, they can go ahead and continue with Prime 95, PC Mark 7, or whatever other stress test application they want. You know, generally in most situations, I would advise at least probably 3 different tests. So something like, you know, PC Mark Vantage, PC Mark 7, maybe Pass Mark burn-in test, Lynx or Prime, or like I said, general usage, and have that be somewhere between maybe about 2 to 4 hours. I think from that point, you should be okay. As we can see there, that's actually, it confirmed on our value, so we still might need to make some other light little adjustments there, but pretty much we've now gone ahead and successfully got to our 4.2 gigahertz. So at this point, like I said, we just go ahead and continue with our stress testing. But I think this shows you definitely some of the positive benefits of being able to do things within the operating system environment.
It's good to know that you definitely want to test multiple different speed tests and burn-in tests to make sure that various CPU applications that you're using are all going to be stable with the overclock that you've set in.
Yeah, definitely. With really the key ones being for the storage and for the graphics. Those guys are very susceptible to these higher level overclocks. So hopefully this gives you a little bit of an overview, and thanks for letting me have the time to go over this.